All right, guys, so Unit 1 Dictionary, Geometry Basics. So this says points, lines, and planes, if you can't read it. This is a definition, and here is example or visual. So on this side, it will be the terms, in the middle will be the definition, and we'll try to give you a picture example here. So this is gonna be the video lesson. It's just gonna be paying attention, right? So I'm gonna read it along, and let's see if you guys could understand. So point. A point is a location with no size or shape. So this is a point, this is a point, this is a point. They're just reference points of locations. Now, line. A line is made up of points with no thickness or width. So it's kind of like a point also. It has no thickness or no width. So it's just letting you know direction pretty much. X and Y points. So this is called line XY. So this is how you draw the symbol for line XY. Now the next one, plane. A plane is a flat surface made up of points and extends indefinitely in all directions. So a plane is not like an aeroplane, right? But a plane is like a piece of paper. That's the best way I could describe it, is a piece of paper that is a plane. So if you have a piece of paper next to you, a post-it, that is an example of a plane. Okay. Now, collinear. So the collinear you'll see a couple times throughout. It means points that lie on the same line. All right, so these P, Q, and R are collinear because they lie on the same line. They're on the same line. So non-collinear is the opposite, right? Points that do not lie on the same line. So here, for example, if I put a point here, so P, Z, Q, R, then this P, Z, Q, R is not collinear, non-collinear. Now, coplanar, right? Coplanar is points that lie on the same plane. So it's like collinear, right? So coplanar, X, Y, and Z. So these points are coplanar because they're on the same piece of paper. So if you draw 3 points on the piece of paper, they're coplanar. Now this cursive P here, that's the name of the plane. That is how you identify the plane. So if I ask a question, what is the name of this plane? And if you say X, that's incorrect. It's P is usually denoted as a cursive P or a cursive letter. Okay. Line segment. A measured part of a line consisting of 2 endpoints. So if you think about it, a string, a piece of string, it has a beginning and it has an end. So this is a line segment. It has 2 definite endpoints, point X, point Y. This is how you write line segment X, Y. Okay. All right, let's continue. Distance formula, you're gonna see this. And it is challenging, I'll give you that. It's just a lot of steps. It's not hard, it's just making sure you write neat, making sure you write organized. So it's a formula used to find the distance between 2 points on a coordinate plane. This is what distance formula is. So for example, X and Y, my point XY, if you remember algebra 2 or algebra 1, it has an XY here, you know, it has a X point and a Y point. This has an X point and a Y point. So you plug those in here and you solve for D, the distance. Let's see, congruent segments. Congruent segments. If 2 segments have the same length, then they are congruent. So if segment AB is 5 feet and segment CD is 5 feet, so then I could say that AB is equal to CD and segment AB is congruent to segment CD. That is what congruent segments are. Now, let's see, midpoint formula. So you'll see this too. It's pretty straightforward. A formula used to find the midpoint between 2 endpoints. So if I wanted to find the middle of A and B, right, I can use this formula, plug it in, that'll give me my X value, plug it in for my Y value, and that'll give me the exact point. So if that's a in-between point here, right? That is how you use midpoint formula. It's just plug and chug. All right, segment bisector, a segment, line, or plane that intersects a segment at its midpoint. So bisector means cut in half. So segment bisector means to cut in half. So now, line L, this is how you write line L. That's the name of this line. It's cutting segment A, B at its midpoint, M. So that is a segment bisector. All right, array, a line that extends indefinitely in one direction. So it starts somewhere, but it doesn't go or end anywhere, right? So it just goes forever. So from here, and it just keeps going on to infinity and beyond, right? So this is how you denote ray PQ. So you start here, and you have a little arrow pointing this way. The line has two arrows on both sides. So this is called a ray. Let's see. Now continuing, this is angles, definition, and visuals. So an angle, the intersection of two rays at an endpoint. So an angle, you have A, B, C, right? So angle A, B, C. B, the vertex is usually in the middle. So that's how you name it. Order matters, order matters, all right? So now my vertex, the common endpoint of an angle where the sides intersect. So these sides right here, AB is a side and BC is also a side, and they intersect at B, at point B. So the vertex is point B. Now here, a right angle is an angle with a degree measure of 90 degrees. So this denotes 90 degrees. So this little square or box, however you want to call it, means that these two lines are 90 degrees. That is a symbol for 90 degrees, right angle. Acute angle, an angle with a degree measure less than 90 degrees. So less than 90 degrees. So if I were to grab this and move it a little bit over here, that will be an acute angle. Now obtuse angles, it goes the other way. So if I were to move my 90 degree to the left over here, then that will be obtuse when it's greater than 90 degrees. So an angle with a degree measure greater than 90 degrees is an obtuse angle. So 120 degrees angle is obtuse. Congruent angles, angles that have the same measure are congruent. So angle A and angle B are congruent because they both have 40-degree angles. So measure angle A is equal to measure angle B. So this is angle A is congruent to angle B. All right, adjacent angles. Two angles that share a common side. So the common side is in the middle, and a vertex. So it's right here, and they're next to each other. So angle angle 1 and angle 2 are adjacent angles. Vertical angles. So again, two angles directly across from each other on intersecting lines, always congruent. So these 1 and 2 are opposite and congruent because they're vertical angles. So measure angle 1 is equal to measure angle 2. So complementary angles, two angles with measures that have a sum of 90 degrees. They do not have to be adjacent. Okay, so here's the thing. Complementary, this word means it adds up to 90 degrees. So 65 plus 25 is 90 degrees. All right, so complementary 90 degrees, complementary 90 degrees. Now supplementary means 180 degrees. So supplementary means 180 degrees. So two angles with measures that have a sum of 180 degrees, they do not have to be adjacent. So here, 120 degrees plus 60 degrees, right, is 180 degrees. So these angles are supplementary. So linear pair. These are adjacent angles that are supplementary. Combined, they form a straight line. So a linear pair, it's kind of is given in the word linear. So a line, it has to be a line right here. So a straight line has 180 degrees. So 120 plus 60 is 180 degrees. And that is how a linear pair is defined. Now, perpendicular. Two lines that intersect at a 90-degree angle, a right angle, the symbol is, it's kind of like an upside down T. That means that L is perpendicular to M. So L is perpendicular to M. So every time you hear perpendicular, you should remember that it means 90 degrees. Angle bisector. Remember about bisector? It cuts it in half. A line or ray that divides an angle into two equal parts. So this line is cutting the angle in half, and these two little lines here means that it's the same as this line here. So this is an angle bisector. It cuts the angle in half. All right. Looks like we are finished. So guys, this is part of your video lesson notes. If you need to go over something else, make sure you go back and rewind it. And you guys even know what rewind is? All right, never mind. So pause, backtrack, forward track, all that good stuff. All right, guys.